We're in the middle of a snowstorm here in Ohio, and it's probably around 3 o'clock exactly. And now we wonder sometimes, this is a grounded device. We're going to look at the solid state transformer. We got a meter over it right there. And it's advertised as being energy efficient. Okay, and we're going to measure that. And we got 2 bulbs in series. But first we're going to measure the open load with no load, and then we're going to show 2 one-ended currents. When I first began investigating all this, from the bars, each of them aluminum bars to the right are contact points for each of them 2 bulbs in series connected by the white wire. In this demonstration, what we're going to do is we're going to open up that white wire, and then it's parallel connected to them 2 sets of pancake coils of maximum mutual inductance. Okay, then we can break the circuit and transmit the energy magnetically instead of by wire. Likewise, we can make another demonstration where we could break the pathway with electric fields. We can do a lot of things if we can use this 20,000 hertz signal. We can explore flux capacitor concepts in the building. What we got is a higher frequency, and this higher frequency really does some amazing things. Okay, now we're looking down there. We're going to see turning on the meter. I recently broke a xenon bulb used in this demonstration, and I required another one from Tony Greer in Lubbock, Texas. He sells bulbs, and he recommended to me to use the fill pressure at 40 torr instead of some earlier bulbs that I had procured that may have been at 10 torr. This torr thing is a pressure thing. I'm not real familiar with any kind of bulb technology, but we're going to turn this thing on then. Look at the open state. Now earlier today we were measuring this, it was at 90, and of course the whole thing is grounded, and when we're looking at these polar currents, we're going to hook up one side and show that effect. It's at 102 milliamps. We're going to move that to the bar. And as you might be able to see on this side, when the polar circuit is taken from that side, it excites the xenon bulb, but it doesn't hardly excite the other one. Now we'll reverse the procedure again. Incidentally, these lightning-like discharges... Oh, bitches! Why did that do that? I don't like that at all. Where's my stick? Son of a bitch. I gotta find the stick. I'll be right back. Didn't do that earlier. Sorry, these delays. Okay, now then we're going to unhook that side. And then we're going to hook up this side. And as we can see, you get a more proficient polar discharge from one of the terminals than you do the other. Like I said, when I first started investigating this, wasn't even getting any discharge from one side. Well, we can focus then in on that. See if we can see that. The coil's in the way. Okay, now what we're going to do is we're going to disrupt the midpoint. And it's going to go to them coils there. And each of them coils have open ends. You can see the wires sticking out. There are 4 layers on each set. And the end wires are open. And then we're going to take that white wire off of there. And see what we get on the broken circuit. I'm going to turn it off. Well, we forgot to show the amperage consumption. Amperage consumption is up around 180 milliamp. Okay, now we're going to turn that off again. Disconnect the white wire. Turn it on. Now that's the signal where the magnetism's going through the midpoint circuit's going through the magnetism of the coils itself. Or as some will argue, the electric field. Now we're going to get over there and separate them coils, and when this happens, an ungodly sound occurs. That out of there. Well, we didn't make a sound today, but that's showing that the discharges are considerably reduced, and they're going through the magnetism of the space of their mutual induction. This we can use for a principle on later ideas, but I think we showed that 40 torr pressure xenon bulb in the background